So, good afternoon, everybody. Wow, it's getting even more crowded. I didn't expect so many people to show up, right? This is just an arbitrary talk about a little bit of code, right? Who wants to know, right? I'm not going to show any prompts, by the way. So if you're only here for the prompts, then you're in the wrong place. Anyway, I'm very happy that you're here. I got the honor of keeping you awake after lunch. That's what Samuel told me yesterday. He said, well, I put you after lunch because, well, you have to keep everybody awake. So I'm going to try. I'm not sure I'm going to succeed. I'm going to do this fast because the problem with this talk is that it's about, well, basically my personal journey into writing code. And that's been a very long journey. I'll illustrate that to you. And there's more and more that I add to this talk, actually. I can actually probably do the whole day because there's all sorts of small things that I really want to tell, but I don't have the time for it. I only have 50 minutes. So I probably should better hurry up, right? So this is my life. I travel and I write code. And I put the beautiful between brackets now because Venkat said, well, if Venkat already says he doesn't write beautiful code, who am I to say that I write beautiful code, right? So I write code. It's what I do every day. I was doing that in the back of the room 15 minutes ago. And that's what this talk is about. So in my case, as you might have realized, I'm an old guy. Looking around the room, I might be maybe the oldest or the second oldest in the room. I'm not going to raise any show of hands, but for me, writing code has been a very long journey. And up to about 15 minutes ago, it was the favorite thing I do in life. Well, there's a few other things, but this is one of them, right? And to show you that it's a long journey, I'm going to show you this. This is the manual of the HP 25. So my dad was a mathematician, so he bought this little machine in 1977 or 78. I can show you because I have proof of it. And I was reading through the manual, and at that point in time, I was like 10, 11 years old, right? You're like, oh, that's late to start programming, right? But back then, there were no machines, right? The internet didn't exist. You need to learn from a book. Remember those? So this is my book, and it says Effortless Programming. It's in Dutch. You won't be able to read it unless you are Dutch, probably, or Belgium. So and then I started reading this thing, and it's all sorts of stuff that you can put in memory and nice and all that. You could program this thing in 49 steps. Realize that, right? 49 steps. That was amazing, by the way. So and it sort of hooked me onto programming. Now, my dad was very meticulous, so he bought this thing in 1977. Right, so I probably started writing code in 1978. And you're probably like, wait, I wasn't even born yet. My parents weren't probably even born yet even. Well, that could be the case these days, right? So, and the nice thing about writing code is that it's basically this. You can never, ever, ever stop learning. And so I've been doing this for a very long time, and I still learn every day, right? And that is what makes writing code or solving problems, as we should say these days, right? It makes it so cool. And you can see that, right? Aristotle's the famous programmer. He has a beard, right? So he must be a programmer. For the things we have to learn before we can do them, we learn by doing them. Or, as you also might call it, the Nike approach, just do it, right? And then the question is, how does learning really work? Now, I started reading about it a long time ago, and I found this model somewhere when Agile started becoming popular 25 years ago. And basically, the Shiori model says, well, first you learn from somebody who's done it before, right? Think Karate Kid. Mr. Miyagi asks him to paint the fence, right, going up and down, and wash the car. I never know whether it's this way or it's this way. It's probably this way, right? I always forget. I should rewatch the movie, right? The original one, of course, the Karate Kid. And then you learn that at some point that when to use the techniques, and they're becoming like muscle memory, right? And then the third step is to transcend from that. That means that you figure out somehow intuitively when the stuff applies that you learn and that you have a muscle memory, and when other stuff is necessary. And that particular part, when other stuff is necessary, makes our industry so fascinating. Let's call it mildly fascinating. And that brings me to the Zen of Programming, right? So what is Zen? Well, Zen is a state of calm attentiveness in which one's actions are guided by intuition, right? And if you think about writing code or solving problems, I'm going to say it's solving problems by now, but it basically means that you sort of know when code is okay, right? You all know that. And it might be different for everybody, but you know when you like some piece of code and you don't. Basically, you like it when you wrote it yourself. I don't even like my own code half years old, right? That's funny, right? Do you sometimes look back at your own code from like a year ago? Do you still like it? No, you don't, right? You know why? Because you got better over that period. And that happens all the time in our industry. And that's pretty cool. I have another model for you. So this is a book by a guy called Gerald Weinberg. Gerald Weinberg was a genius. He died a long time ago, but he wrote this book, Becoming a Technical Leader. In this book, he tried to figure out how learning worked for him. And he did that by doing an experiment. His experiment was, I'm going to play pinball on the pinball machine in my local pub, or bar probably, because he was from the US. My expectation is that I get better if I play on the same machine over time, and that's a linear progress. So he started writing down all the results, and he realized that it wasn't very much linear at all. It went a bit like this. And you're like, what? What does that mean? And if you look at the individual scores that he drew in the diagram, this is actually a diagram from the book. That's why you see the printed letters through it, right? So, and he realized at some point, he said, well, there's something weird going on. And if you make it into a model, it looks a bit like this. So what are these potholes here? Well, these potholes are when you get stuck at a certain point and you're doing everything you can with how far you got so far, and then you realize that you need to try something differently. In his case, one of the experiments he had is like, if you play multi-ball on modern pinball machines, they have this thing called multi-ball. Did you guys ever play a pinball machine? Yeah, well, multi-ball, right? And then he said, well, I was trying to keep all these balls into play, and then usually what happens if you don't pay attention or something weird happens, and they're all gone at the same time, right? And you're like, what? And he said, what if I keep my eye on one of them? And the other ones, when they pass by, fine, I'll just flip her along and do something. But one I'm going to keep in play so I can continue playing. And he tried that out. Actually, I've tried it out too. And the machine I was trying it out on, I broke the all-time record on a machine. Pretty cool. I'm not even very good at playing pinball. And then he realized, yes, I do these experiments at some point in time to get better. And then all of a sudden, you have far better results. But before that, you have to do the experiment. And experiments can also fail, right? So you try something out. It doesn't work at first. You try again and again until you got to this point of, hey, now I can be much better. And for me, my whole, let's say, 45 years of programming has been a bit like this. I've had these epiphanies, and I've done these experiments all the time, and you probably also have that. That's probably the first realization if you listen to this talk. Wait, I have this too. I have these ideas at certain points in time, fairly random, that I'm trying to solve something complicated. I can't solve it. I'm on my bicycle, I'm in the train, under the shower, in the car, having dinner, playing my, whatever, right? Playing my guitar, stuff like that. And all of a sudden you're like, wait, I'm going to try this. And it doesn't work at first, right? Or it might. And then you try again. And you're like, oh, wait, what if I do this? And I do this. And all of a sudden, you got a lot better. And those points interested me. And that's when I started writing this talk. Now, before that, I had to go through this, right? Because it's not just learning 45 years or 50 years soon. It's also about unlearning. I found this really nice chart on the internet that says, well, at some point in time, and this is basically my programming career in a nutshell, right? So in the 70s and 80s, I was writing super simple code because I didn't know anything else besides it. Right? And then the design patterns book came. I started reading about OO, of course, which was fairly new when I started programming. And then the design patterns book came about, oh yeah, we have to have all these design patterns in our code. And then I started working for large financial organizations, and they came up with 13 layers of architecture. It's what financial institutions do, basically, right? And you have to write all these abstractions and layers and stuff, and nothing works, and it takes forever. Until some point you realize, I'm not going to do this anymore. For me, that was 2015, I think, 2014, actually. I was working for an insurance company. I'm like, no, this is not the way I want to write code. I want to write code that I can push to production within 3 months instead of half a year or how long it ever takes, right? And I started going down, and I was like, I want to know what it's like to write super simple code again. And I'm not 100% sure where I am now, right? I could be here. I could be getting to a point that I can write even simpler code. I don't know, right? It could also be that I'm already here. In that case, I should probably retire or start solving problems instead of writing code. But I like writing code so much, right? So I've always been, well, at least the last 15 years of my life, on a quest for super simple code. And I'm going to show you some of these epiphanies. And there's a whole bunch more. I'm just going to show a bunch of that I really, really like. So basically you got here, right? So how do you do this? I don't know. I just try to figure out myself. So this is me. I'm Sander. I'm a single independent dad. I speak a bit, I write a bit. I do CTO roles mostly because then I can both mingle with the strategy of a company and write code every day, which I really like. So I'm basically a lifelong programmer. And as you can see from the picture, I only have one t-shirt. It's not true. I have another one, actually. So and to prove to you that I'm actually a programmer, I am double object-oriented. Only the Dutch can say this, right? So even in Dutch, this is not a very common name. It gets worse, by the way, because I live in Amsterdam. I live in the Java Street. This is no joke, by the way. This is literally the view from my window. So, and I do a little bit of contribution to open source as well. This is our TypeScript framework for writing microservices. But just give it a star if you like. I like it. We don't have that many stars. So yes, a quest for super simple code. And it started a very, very long time ago. Oh, wait, I have to say this, right? So all the techniques that I will be showing you, they work for my team and for me, sometimes personally, sometimes not even for my team. But your context might be different, right? Or is probably different, which means you might say, no, this cannot work for us. That's also fine, right? I'm not here to improve the world. I tried that, didn't work well, and now I'm just trying to improve my own code. The thing is here, you need to realize that you're never there, right? You can always get better at what you do. And that is what I like so much about being in this field. And it was illustrated quite well by my first mentor, a guy called Wim, and he said, well, it's basically like a wall in the desert. This is in Jordan, I think. Oh, it's Wadi Rum in Jordan. So, and he said, well, imagine, and this is a long time ago, so this is early 90s, and Wim said, imagine walking in the desert. There's a thick fog, and you can only see about 30 centimeters far. Now, there might be a wall in front of you, or there might not, right? Imagine this. And you're walking, and you have no idea whether you're going to bump into this wall or not, whether that wall is even there. And he said, that's what's programming all about, is that you can bump into a wall and get totally stuck, or you might not, and you have a good day, right? That is what programming is. And then Donald Rumsfeld, the great programmer Donald Rumsfeld, well, and he had this metaphor, and he says, well, there's the known knowns, right? The things we know, we know. And then there's the known unknowns. Those are the things we know we don't know, right? I was in a talk about MCP this morning, and we are just about to start trying it out, my team and I. And so we know that we don't know what this is going to do and how this is going to work. We also know that we will figure it out. And otherwise, Chat will figure it out for us because it's its own stuff, right? So it should know. And it's an it, right? So, and but then he says, there's also the unknown unknowns. Now, this is where it gets interesting. The ones we know we don't know. The ones we know we don't know, right? And if one looks throughout the history, it's the latter category that tends to be the difficult ones. Wow. It's the stuff you don't know. And we all have this stuff. Right? We all have the things like, there were so many people in the MCP talk this morning that I was like, oh, there's a lot of people who have no idea that this even exists, well, barely, and how to do this stuff. So if you want to use this stuff, you need to figure it out. So you need to experiment towards where you figure it out. And then there's the managers, right? And the managers say, yeah, all fine, Sander, I'll make your own unknowns. And so everybody in the company now uses it against me, but he said, when will my project be done? And the only thing you can say is, I don't know. That's the honest answer, right? And then he said, give me a number. I'm like, 42. And they don't laugh, right? They're like, 42 days or 42 weeks? What do you mean? No, just 42. And it's like, so I put it on my arm, right? So it makes sure that everybody can see it's 42. So, in fact, I think that we should not be talking about productivity at all, right? You shouldn't be measuring in function points or lines of code or commits, because if you start measuring that kind of stuff, we will behave like that. Our CEO said, why can't I just count the number of commits people make? And I'm like, you can do that, but within 2 weeks, they'll make double the amount of commits that they do now, because you measure that stuff, right? There's a law for that. So productivity in software development, you cannot say we're going to build 2 software, because every piece of software you write is different from the one you wrote before. If that wasn't the case, then Chat could write, oh, it can actually write all our code. But before that, you weren't just copying your own code in the next thing. It's not like cars from a production line. We're solving actual complex problems. So there is no such thing as productivity. And then people are like, yeah, but you can count the amount of hours that we type stuff. And I'm like, no, because software, you don't write software on the keyboard. Well, eventually you do, but most of the time it happens here, right? And that is what you need to figure out. Ken Beck said it pretty well. Ken Beck, at one point in time in 2003 at a conference, I took this picture a long time ago, he said, I'm not going to refactor the code just yet because the code doesn't know yet where it wants to go. And I was like, I saw this and I'm like, what does he say? And it took me a long time to figure it out. What I think he means is that stuff takes place in you solve the problems in your head, while in the shower, in your car, wherever you are, right? Not necessarily at work. And especially not necessarily from 9 to 5. But at some point in time, and then you solve the puzzle in your head, you try typing it out, it fails the first time, you do the experiment, and you come out better. So, in my opinion, soft programming doesn't fit really well into time boxes. That means that everything that is a time box, that is about to fail. It doesn't also fit 9 to 5. I don't solve problems from 9 to 5. That's not how it works. I can do meetings from 9 to 5, well, from 9 to 10 basically, and then my mind stops, but it's a bit like this. We are not working from 9 to 5. Our minds work all the time. That costed me 2 very good relationships in my life. What are you thinking about? Well, if I do this if construction, if I do, and I'm like, no, you're probably thinking about somebody else. No, yeah, just TypeScript in my head. No, stuff like that, right? And the thing is, if you want to be good at this stuff, you need to be able to travel light, right? That means all the stuff that doesn't belong in your head, or that doesn't have to be in your head, if that's out of there, you can solve bigger puzzles. So I learned to travel light, not just physically. This is actually literally my only backpack I have left. Whether I travel 1 week or 2 weeks, it's the same one. But yeah, I just drop stuff off and I buy new stuff. No, just kidding. But so I learned to travel light. And we're not good at this as developers because we are sort of drawn to complexity. As Neil says, developers are drawn to complexity like moths are to a flame, and often with the same result. We burn ourselves all the time. Organizations burn themselves, right? Gregor says it well too. He says excessive complexity is nature's punishment for organizations that are unable to make decisions. That's the nice thing. And we are in the middle of this stuff, right? And what do? Well, we optimize prematurely all the time. We solve problems we don't actually have right now. We all do this. I'll give you some sentences to follow up on it. And we do this not because it's easy, but because we think it will be easy. And it never is, right? It never actually is. So stuff like this, right? So we might need this in the future. Do you sometimes say this? Yes, you do. Eventually, we will need this stuff, right? Or if I write my code more generic now, we will benefit from it later. It's not true. Or this one. You've all done this, right? Yes, but what if we want to replace this database, MySQL, by another at some point in time, Oracle, or the other way around, or whatever. So we built all these stupid ORMs in between our code, making it very complex. Nobody ever exchanges the database for another one, right? Have you ever done it? See? Or you don't dare to raise your hand. That could also be very well possible. But this is the thing, and we all do this. Premature optimization is highly expensive. People start doing microservices because they think they have a scalability issue. Most of you do not have scalability issues. Probably. Maybe you do. But we all built this into our code. Yes, it needs to be scalable. To what? To 10,000 users? That's easy, right? That's not a scalability issue. And then it takes into account Hofstadter's law, of course, right? Which says it always takes longer than you expect, even when you take into account Hofstadter's law. So, the conclusion is this. This was the lesson I learned. I can only spend my time once. My team can only spend their time once. That means you need to spend it on the right stuff and not on the stuff that you might need somewhere in the future. By the time you get to the future, life will have changed, right? AI will have taken over, whatever, right? So the question you should always ask yourself is, do we really need this now? Or to emphasize it, do we really need this now? If the answer is no, don't spend time on it. It helps a lot from getting stuff out of your head, right? So you need to favor simplicity. And the reason for this is very simple. The reason is code is cost. Code is not value. Unfortunately, I wish it was, because I've written so much code. I would be a millionaire by now. But it is not, right? We deliver business value. And yes, we write code to do that. But the thing with code is, it's costing a lot of money. The more code you write, the more expensive it gets. Because you need to test it, you need to refactor it, you need to maintain it for 25 years long. Right? That's expensive. So you need to think different about this stuff. Like, simple code is good. Right? This is code from one of my teammates, and she wrote this. It's test code in Jest. I was looking into it, and I'm like, I can write this simpler. So I rewrote it. It's basically what I do. I rewrite other people's code. I just love doing that. It's just fun, just to annoy them. And this is less code, meaning it's less maintenance, meaning it's easier to test, it's easier to read. And the conclusion I got here is that the easiest code to maintain is the code you do not write. The less code you write, the easier it is to maintain your code, right? Fairly simple. So I started moving towards writing my code very differently. I was like, what if I only write very small, simple functions and nothing else, right? No functions longer than one statement. Can you do that? Well, if you write fluent code and functional code, yes, of course you can. This is highly functional code, of course, but it's a single statement. And the nice thing is, well, you don't see a return, right? This is TypeScript. You don't necessarily have to do that all the time. I can show you with returns as well, because the thing is what I started to do, and I've been doing this for probably 15 years now. Every time I start writing a new function, the first word I write is return. Most people will write it the other way around, right? You write a lot of code, and eventually you return some, or halfway and there, making it hard to test. I just start with a return. So to figure out, how do I get here? So my questions about what to write become very differently. And I do this all the time. Well, in TypeScript, you don't necessarily always do it. I write a lot of TypeScript. But and I started to think about, how can I make my code more readable? And I started looking into naming things, right? This is from Spring. It's like the abstract annotation config dispatch servlet initializer. It's pretty concise, right? It describes exactly what it is doing. It's just so long. And then what people tend to do is they tend to name the variables the same as the name of the class. This is code from a friend of mine. It's Java. And he has the chat message context. So the variable is also called chat message context, while the function is only 4 lines long. So we did this at some point in time, and I know because I'm old, because, well, we didn't have IDEs, right? We just had text editors. That means that if I drag my variable and I use it 30 lines down, and I don't know what the type anymore is, I need to scroll up and see what the type is. We have IDEs these days, right? We have WebStorm, we have Cursor, we have IntelliJ, we have Visual Studio, if people still use that. And so I might as well call this thing C or CMC for that matter, right? So you can still know what it is without having to type that full long name. Because in Java, most Java people do it, right? They write, these functions are always like this wide. They barely fit into your window. It's sad, right? Just make it shorter. So we started doing stuff like this, right? Yeah, okay, it's a gateway. I know it's a gateway, but it's just delivering comments to me. So why don't I just call it comments? Or variables to function, it's a comment, so I'm going to call it C. There's no reason for me to call it comment because the function is only this long, so I can see immediately what it is. Most of us do this, right? So I stopped doing that. So my variables basically come 1, 2, 3 characters, and it's a joy, basically, because it's so much easier to read. Again, right, this is in my context, doesn't mean you should do this too. You're like, no, you cannot do that in Java. Of course you can, right? Even in COBOL if you want to. So the most secure code to continue is also the code you don't write, right? Every line you don't write is not a security risk. It's that simple, right? So life becomes simple if you look at these talks, right? Also, please don't do it. Please don't leave commented out code in your code because every time somebody else looks at your code, they're like, why did they leave it in? Why is it commented? Why is that version better than that version? And they start to worry about all sorts of things. And you don't need to keep it in. We have something called version control, right? It was invented a long time ago, by the way. I wrote code before there was version control. I can't tell you how hard it was. It was really hard. It was awesome, basically. But don't do this because you confuse people. Just leave it out, right? Don't put it in or leave it in. Throw it out. The previous version in your history will show it anyway, right? Because it was there before. So, a little bit about architecture. This is the Colosseum. It's a beautiful piece of architecture. It doesn't fully function anymore what it was for originally, but they even held naval battles here. Can you imagine? They put water in it and ships on top of it. Awesome, right? These guys were really good at architecture, right? So what's the thing about architecture? Well, I think it needs to be, well, let's call it agile. It's sort of like a contaminated word, but I like it anyway, right? So the great Java programmer Darwin, he once said, it's not the strongest of the architectures that survive, nor the most complex. It's the one that is most adaptable to change. It's actually the same quote Venkat used this morning, but I'm not sure who's got it first. Doesn't matter, right? So, and I started realizing I wrote a book about, but it had some architecture. It was basically a book about UML. Forget about that. Don't blame me for it. It was there, and it was good. And there's an architecture in there. I'll show you the architecture. Not to say you need to use this architecture, but just to say, hey, you can write simple architectures, and you can make your code look like this all the time. So it has a bunch of sort of like layers. It's centered, right? You start with a domain. That's where your entities live and your value objects. And then there's the repositories that sit around it. It's still part of your domain, right? And a repository is a thing that gets your entities from somewhere and puts them back into that place. That's basically the pattern. And then we have use cases on top of it. Why do we have use cases? Well, we grow into it. It's nice. It has let's say, the process code in there. And it also, we use it for authorization, authentication, stuff like that. Again, you don't need to do this, but it's the way we do it. And then there's the service layer. That's where the requests come in, and they handle it, and they pass it on to the rest of the architecture, and they make it work. And underneath, you go to whatever data source you have, right? Whether that's an MCP server, or but you need to do modern stuff, right? Or whether it's a database, or a document database, or another service, whatever, it doesn't matter, right? And the funny thing is, I stuck to this architecture for about 25 years already, and we still use it every day. If we open up any of our code bases, you can see this architecture, right? It looks a bit like this. This is a .NET code base from 2014, the last commits, I think. And you can see those different layers are in there, right? And you can see that a repository in C# looks a bit like this. A repository in Java, functional code, by the way, in Java, looks a bit like this. This is from 2015 from one of my projects. It's the same thing, right? It uses a gateway to get to the data, and it has a bunch of functions that deliver me instances of entities. That's what it does. You can also do it in Python. It just looks a bit horrible, but you still might do it. No, just kidding. No, not actually. But no. And here's one in TypeScript. These are even shorter now because we put them all in the repo in our library. But it's the thing, right? We even don't name it repository anymore. It's now called repo, shorter. And the thing is, I've been using the same architecture style for years and years, and it's still kind of nice to do. And again, if you have a small team, which I have a team of 13 people. I don't want to have a bigger team. I like working with small teams. It's much more tangible, and it's much more, you can do stuff yourself, right? And we have like 170 repos by now. In that case, we do a microservice architecture. In that case, it's really nice to have all your repos if you open them up, and you can see the architecture reflect a simple picture, right? And it makes opening other people's code up easy to read. So simple techniques like these help you get through the day. And we have moved everything to a single stack, so everything with us is TypeScript and React and Node and stuff. And because I only have a small team, I don't want to have 20 different programming languages. It just makes stuff hard. It's just documented also in our library. Doesn't really matter. It's an example of the fact that if you go through a simple architecture, remove all the fluff from it, you're in a better place to continue working, right? Now a little bit about history. So what's with history? And the thing with history is that there's a whole bunch of literature out there for a very long time with a lot of wisdom in it. And we are not really good in our industry in keeping that wisdom alive. We just go on, next, it's now AI. Next will be quantum computing, right? In like 5 years' time, nobody will talk about AI anymore because that's everyday work. We'll talk about quantum computing. Yes, that's really going to change our job, and we're going to lose all our jobs because quantum computing can blah, 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 in combination with AI or whatever we do, right? And it's just evolving. But there's so much wisdom in there. Simple stuff, like talking about low coupling and high cohesion, right? How do you break up stuff? I learned this a very, very long time ago, and I still do this every day. This simple picture was, to me, a change in how I wrote code too, because you want high cohesion. That means the things that belong together should stay together. And if you look at a monolithic application and you put all your repositories in one big folder, that's not high cohesion. That is basically high coupling, because those things actually don't have anything to do with each other. A repository for an account does have nothing to do with a repository for an order, or for whatever you have, a claim further down the road. They don't belong together. And the question is, when does stuff belong together? Well, there's some philosophies about that. In 1976, they wrote down the Unix philosophy that says, write programs that do one thing and do that really well. And then the solid principles were published, right? And actually, Bob Martin says pretty much the same. He says, gather together the things that change for the same reasons. Separate things that change for different reasons. So that means if you have stuff that works on an order, like an order repo, and in my case, some order use cases, and an order gateway, and an order entity, some value objects, order line object, etc. That's the stuff you put together. Because that's the stuff that actually changes together. And that's what he's talking about, right? If they change together, put them together. So that is actually a nice start to do, for instance, microservices. Really works well. And if you look into the intuitive of when is something single responsibility, it also goes down to code. Because if you have like 352 lines of code in a single file, I have sort of like intuitively the hairs on my back, I don't know if I have any, but the hairs on my back will rise for this, right? So, or something like this. This is a repository that has 5 gateways. I'm like, why would you need 5 gateways? It's a bit much, right? And then you look at the code, and it looks a bit like this. It still looks pretty simple, but if you look at this function here, it takes so much stuff in there and puts it together that you might like, just pull it apart, right? Do that. And then there's one more thing, and this is also coming from Bob Martin. He says, well, it's originally called the Boy Scout rule, but that's not very nice, right? So I call it the Scout rule. So always leave the campsite a little bit cleaner than you found it. I do that all the time. If I look at my own code or somebody else's code, doesn't matter. If I find something like, this can be slightly better, I'll clean it up. Because I'm trying to help the other people on my team, right? Just as they try to help me. If I don't have enough coverage on my code, I check my code in, I just checked in some code, it could be the case, then somebody in my team will probably now be writing a unit test to that to make sure that it has the right coverage. And we do that in reverse as well, right? So cleaning up the code in your team is actually a good thing, and you should allow yourself to do that. Actually, you should do it all the time. And I think we're sort of getting back here, right? Like, it's guided by intuition. Now, there's an interesting topic that I would like to address. It's a little bit more advanced, and I'm going to try and explain it in 3 minutes, but it changed my life as a programmer so much that I want to push it in, even if it means I go a little bit over time. So I'm going to do this anyway. Most programming languages can do this, right? They can pass functions as parameters. Even Java, since version 8, which is a very long time ago, can do this. Not a lot of people recognize that you can do this, but it opens up a vast new amount of possibilities in your code. And at one point, we were looking at Scala. We just looked at it, right? We didn't write it. It's just the Scala has to look at, basically. And we found this thing called a try class. Now, a try is a monad. Have you heard of monads? See, that's why I'm pushing this part in, because that is fundamentally can probably change the way you write code forever. It did for me. So let's talk a little bit about monads. And I said I'm going to do this quickly, but that is very hard because Douglas Crockford says, monads are amazing, right? They are simple things, almost trivially implemented, with enormous power to manage complexity. That sounds really good, right? The problem with monads is, and if you look at talks about monads at conferences, they usually go into all sorts of mathematical function theory and stuff like that. Nobody understands that stuff, right? So I'm going to try and explain it to you very simply. But the problem is, he says, if you understand them, which is hard, and most people who do seem to lose the ability to explain them to others. Still, I'm going to try, because for me, this was probably the most fundamental change in how I wrote code. And I started looking into this in 2014, 2015, and let me explain it to you. So, a monad is basically a box. And the thing that you want to reason about, the blue ball, is the subject. And you put it in the box, right? And then what you can do is you can pass functions to the box, because your programming language allows you to, that will act on the thing that sits inside of the box. But because the box protects your object, it can take away side effects, like try-catch blocks, failing stuff, all sorts of side effects you don't really want in your code. Like, well, the stuff that you normally write try-catch blocks for, right? Do you write try-catch blocks? I never do. There's only one left in my code, and it sits inside of one of these monads. In our case, basically, it's the promise. And the nice thing you can do is you pass in a function to the box is going to apply it to your object. If that succeeds, you create another box with a transformed object in it. You're like, ooh, this is also very mathematical. It's actually quite simple. But, and you can do that as long as you want, right? Just push functions into the box, and the box takes away the side effects for breaking stuff, validations, printing, logging, whatever you can do, right? And eventually, at some point, you'll get it out of the box with let's say a get method. Let's call it the get method. And that's an easy thing to do. Now, if you look at how these things are built up, this isn't a good example, right? So the gateway by ID here, what it does under the hood, because I haven't got the code on the slide, it will create a promise of type, probably of type JSON in this case, and then on that thing, which is the JSON here that sits inside of the box, I can throw in a lambda that does something, and if it succeeds, it will go here. And then it will continuously continue here if it succeeds. If it fails, there's one catch blocks, but that's all the way up in the end. Actually, it's in our framework somewhere, but it doesn't really matter. So you can do all sorts of stuff and chain all this behavior without having to look into, well, does any one of these lines actually break somewhere? And we wrote normal. You can write many of these monads. This is also a monad. We call it the when monads in our framework. When J is not defined, reject. Something simple, right? You don't have to look into how it works or that it will break or whatever, a try-catch block. So you can make really compact and very robust code with this stuff. I'll give you one more example, and then I'm going to continue because I'm running a little bit late on schedule. This is a choose query, or actually we call it the switch. But again, what this does, it says, well, you push in the query, which is the object that sits inside of my monad, so the choose is the monad, and I can call all sorts of functions on it that I have defined on the box, but that pass in one, or in this case two lambdas, two functions basically, that act on that particular thing. So if is defined q new means if there's a new property on the query thing, then do this. And then please skip all the other ones and go to the end. And the end, this is actually the function that gets the stuff out again, and it has a default parameter for if something fails. This, again, saves us from having to write all sorts of try-catch blocks in our code. So our code doesn't have try-catch blocks. Can you imagine that? How much of a relief that is to if you write code? Well, let's do the next thing, right? So I'm going to skip this a bit because I'm running a little bit late. Again, so the promise in JavaScript, by the way, is a very good example of a monad, right? It is one of the best monads there is. So let's talk about testing. Do we all write unit tests? I don't believe you, actually, to be honest. Because every time I do this, a lot of people say, yeah, well, actually, we don't. So what's it for? Well, this is a bunch of unit tests, right? So what's the thing with unit tests? Well, they help you in the long run to see if your code still works. And that's a good thing. And a lot of people, yeah, but I don't like writing unit tests. Well, you let Chat write the unit test, right? Or Cursor, or whatever you use, Claude, or whatever, right? The nice thing is, a unit test is basically a thing in isolation, right? It's to check whether a simple function works, or a simple object, all its functions work if you make it a little bit larger. But if you write single statement functions, the actual tests that you have to write are pretty precise and pretty compact too. And I realized at one point in time that writing these unit tests is not so much a testing technique, it's a design technique. And a lot of people say, yeah, you're talking about TDD. No, not necessarily TDD, that's a step up, right? And you don't always have to do that. You might, it's a good strategy, I like it, but not all the time. Now, what's design actually? Gerald Weinberg says that design is the progressive elimination of ambiguity, right? You remove stuff that you're not certain about. And that is what these tests are for. And Dave Farley, I follow his advice for this, actually. He says, well, instead of writing the test in assuming that we're going to be right, that the code will actually work, you need to assume that you're actually wrong, that the code doesn't work. A good friend of mine who's on my team, he always says when we write code together, he says, yeah, it should work. And I'm like, how do you know? He said, okay, you're right. And then he starts writing the tests, right? But and that's what most of these people, most of us do, right? So I do it a little bit different. And once I started realizing that if I start from wrong, then I reason differently about this code. It's pretty similar to starting with return on your code, right? It's this is the code I was reasoning about. I write an empty function, right? So, and then I write a test. Okay, here's the if I don't provide scopes, that means you're not allowed. That should work, right? Well, because, well, it's returning false, right? So it does work. I'm pretty sure it does. Cool. I have a single test and I have code that doesn't do anything. And then I'm setting up the signature of the function. Okay, we need to throw in scopes, which are ideas, and then it needs to work. So I can run the test again. I see what happens, right? And then I start writing tests in the assumption that the code needs to fail, because that is also expected behavior. So I write a whole bunch of them, and then I'll probably end up with the last one that actually provides me the test case for when it's actually working. And I run the test, and hey, they're all green except for this one, because I haven't written any code yet, right? So, oh yes, let's write some code. So I write the actual function, which is very short. By the way, this is one of the crucial functions in our code, because it tells if you're allowed to do something, which is kind of crucial. And then I'm running the test again, and if they're all green, I probably have done this right. Over time, if you do this all the time, the result is that you can code with a lot more confidence than you ever did before. So you don't have to pray for your code to work, right? This is an actual programmer on one of my teams a long time ago, and you can see why he's praying, right? He's working in light mode. Who does that stuff, right? So yeah, that's the nice thing about it. And then I started realizing, so we started moving in towards Agile, right? And okay, you might like Agile. By the way, Agile is not Scrum. Scrum is not Agile. Scrum has nothing to do with Agile, right? You can do Scrum without being Agile at all, right? Agile means you can adapt to changes. Scrum is not really good at that, or people who do Scrum. But the nice thing is, the shorter your cycles, the easier and the faster you get feedback on what you do. And that can go a very long way. Now, of course, you need to have an Edwards Deming quote in your talk. And Deming says, eliminate the need for massive inspection by building quality into the product in the first place. What does that mean? In my case, it means this. And you're like, what? No pull? You cannot do no pull request. Yes, you can. And it works. The nice thing is, building quality into the product in the first place is not necessarily pull request, and by the way, code reviews for that same matter. Because code reviews, if you do a pull request and you have to wait for somebody to review your code, when is that going to happen? Same day? If you're lucky. Same week? Could be. Next week? Maybe, right? It takes time. And the thing is that they usually they review your formatting and your linting, right? I have ESLint for that, right? You don't need to do this. Usually they're not very useful, but it takes time. And they come back to you and they're like, you did this wrong. If they even know what you're writing. So if your code is complex, people reviewing it will have a hard time understanding it. That's, by the way, also an anti-pattern. But what if you don't do this? What if you just work together on writing the code and then push it? So you can have together, you have already seen that the code is okay. Or okay enough, right? So AI will do the rest. So that's why we moved to trunk-based development. Who of you is doing that? Do it. As of tomorrow. What day is it tomorrow? I don't know. Anyway, so here's the thing. Trunk-based development means I pull my code, make a change, and I push it back in to the main, or the trunk. Not to the master. We don't do that anymore, right? And what's the reason? The reason for that is that if you wait longer, if you start branching, that means you feel safe inside of your branch, right? And you write your whole feature, it takes 4 weeks. You write a big feature because, well, you're on a branch anyway, so you feel safe until you need to merge back, right? That's when the shit hits the fan. It gets bad because, well, other people have made changes to the same code base as well. Now what? What if you just do it 50 times per day? Well, that's a bit much. I think I'd probably do this 10, 20 times per day. I make a very tiny change. Sometimes it's one line of code. And then I push it. Nobody's bothered by that because nobody has made a change in the meantime if you're very short at this. And that is why trunk-based development moves you towards making stuff smaller. And making stuff smaller is good, right? So you can start delivering value continuously. What does that mean? Well, Just Humble says, continuous delivery means if it hurts, you need to do it more often and bring the pain forward. This is about software development, right? So not to confuse it with other stuff. So that means that if you only release, let's say, once every 3 months, and you have this ton of changes, it's hard, right? It's hard to merge it back and do all the integration tests and the system tests and the end-to-end tests and whatever you do, right? And that makes you slow, meaning the feedback cycles lengthen and lengthen. That means you get slower and slower. What if you turn it around? This is one of the crucial slides in the deck. And you're like, what? It's like a metro station. Yes, it is. It's in Budapest. And I was at the station, and I took this picture because the next train comes in 1 minute. And the one after that comes in 3.5 minutes. So what's the result in this? Do I rush towards the train? No, I don't care, because the other one is 2.5 minutes later. And Jason Gorman put this in a statement. He says, missing the bus is not a big deal if you know there'll be another one along in 5 minutes. Think about that, right? If you only release every 3 months or even every 2 weeks for the Scrum people in the audience, that's a long period of time, right? That means you have to get everything in there. And you never make that, right? Because it's always hard to put stuff in there in something that's only releasable once every 3 months. That's why my team, we release 50 to 80 times per day to production directly. And again, this is our context, right? That doesn't mean you should do this too, but you should probably try to move towards that direction. Meaning that all these small changes that you can make, the delta between one change and the next change is like this. That means that the chances that that goes wrong are not very big. And that's the nice thing about it, right? So I'm going to go to, well, 2 more things, right? I want to tell a little bit. I'm going a little bit of overtime. Is that okay? Is there a break after this? Or Samuel just comes in. I wasn't here. And so we're in a very complex industry. How complex? The most complex industry out there. Software development is the most complex. And it only gets more complex, right? We continuously need to adopt new things and keep the old ones alive. And Dijkstra says, the programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. Imagine you work in a software company and this is their stack. This is literally a stack from one of the companies I worked for. We had 30 people on board. You know what happened to the company? They died. Well, they went bankrupt, let's put it nicely, right? So it's because they have all these dependencies, they will kill you. And it got me to the realization that there's so much in this industry, even having been here for 45 years, there's so much shit I don't know. And that means I cannot write software on my own. Software is not an individual sport. It's not like javelin or what do you call it with the bullets, I don't know what the sports, it's a team sport, right? You do this together. And you do it for each other, right? You help each other out. So the smallest unit of ownership is the team. And if you're not used to that, you need to learn this. And you learn by doing. It's the Nike approach. And you need to allow yourself to experiment. Because you don't know what the outcomes is. These are the unknown unknowns. And to get through the unknown unknowns, you need to experiment. Even Bezos says it, right? He says to invent or innovate, you have to experiment. If you know it's going to work, it's not an experiment. Think about that. If you think you're doing an experiment, you already know what the outcome will be. You're not experimenting. You're doing the same thing. And to solve the problems that are one level above where you are, you need to go to that level. And that you can only do by experimenting. That requires autonomy. I am going a little bit overhead, actually. And the problem with autonomy, that it's very hard to learn. As the manager of my team, I hate that word, by the way, but I just write code with people. And I can tell you, well, if you want to draw an owl, start with 2 circles. And the rest, figure it out for yourself, right? We don't know. And what do? Well, we solve a single problem every day. And the thing we realized is basically this. We follow this principle. This is another one of the powerful slides in the deck. This is D. Hawk, the CEO for Visa, and he says, simple, clear purpose and principles give rise to complex and intelligent behavior. Complex rules and regulations give rise to simple and stupid behavior. Now you need to ask yourself, which of the two are you looking for? Do you want people to do intelligent stuff? Do you want them to solve the problems that are one level above where you are now? In that case, you need to take away the rules. You need to simplify to amplify. So we took away most of the rules from what we did. And rules could be anything that you consider like ceremonies or whatever you do. And I'll show you what we took out. This is a crossroads near where I live in Amsterdam, and they took away the traffic lights. What happened is, people started to communicate. They started to show intelligent behavior at the crossroad, except BMW drivers. But the other people on the crossroads pretty much do the right thing. And that's the thing. Perfection is achieved not when there's nothing left to add, but when there's nothing left to take away. I'll show you what we took away. This is my team, and this is what we don't do. We don't do Scrum. Power to the people. That doesn't mean we do Kanban. It's not either or. It's just whatever we do. It doesn't have a name what we do, right? We don't have sprints. If you release 50 times per day, what would you use a sprint for? It doesn't matter. Retrospective are too late. They're useless and boring, by the way. We don't have a Scrum Master. Well, we don't do Scrum. We don't have product owners. We do it ourselves, basically, right? We go out to the business and we talk, what do you really want, people? And so we don't have testers either because everything's automated, right? We don't have stories. We only do ballpark estimates. Everybody's an architect. I was at an architecture conference last week and I said, no, we are the architects. Old people, jackets on, and fine, right? So we don't do branching, we don't do pull requests, and most of all, we don't blame. We take care of each other, right? This is the stuff that we do. So I'm going to tell you one more thing, and that's this. This is my mom on the left side. Yeah, we look a lot like each other. And there was a time I used to have hair and no beard, right? But that was a long time ago. But I got back from a vacation. I think I was in Italy, and I showed her our holiday pictures, and she was like, "Oh, that looks really nice. Why didn't we?" And she meant my dad and her never go to Italy. And I said, "Well, you guys always went to the same campsite in France for 25 years, and there's nothing wrong with that. If that makes you tick, fine, right? Go to the same fucking campsite in France all the time. By the way, the pool was terrible, and they made me go there with my kids as well. Terrible. But she was perfectly happy with that. The thing is, if you want to ignite that change, right? If you want to go through these potholes and figure out what's on the next level, stuff you don't know, right? The unknown unknowns. There's only one thing you can do, is that you can't do this. This is what my brother-in-law posted. He says, oh, basically, this is the same thing, right? Old keys won't open new doors. That's it, basically, right? There is no such thing as solving the next level problems with the stuff you already know. You need to go to that next level, right? You need to go through the potholes. And a lot of people don't like change. I do, right? I ride a tuk-tuk on, Sri Lanka, even though people get killed doing that themselves, right? They laughed at us really loudly. Still, it was nice. And the thing is, if you want to change stuff, you should try this out once, right? This is really cool. I actually tried it out once at the football team, and I'm like, well, I'm just going to park my car the other way around. See what happens. Other people started doing it too, right? It's a motion, but there's only one person who can ignite that motion. That is you, right? It's you that makes it tick. So you can never be afraid of asking newcomer questions. Do that all the time, even with the 45 years in this industry. I still ask the stupid questions. I don't care, right? These are not stupid questions. They're the stuff I don't know. And there's always lots I don't know. So you can never stop learning. You need to simplify, right? Start taking away stuff from the ceremonies that you have and the procedures that you use. See what happens, right? If it makes you happier, leave it out. Never bring it forward again, right? Stop doing retros, whatever. And also, we're in the best industry to have fun in, right? It's the most fun industry I've ever been in my life. I've only been in one industry, so it doesn't matter. But oh, by the way, if everything else fails, you tried everything, you can always remove your node mod, just do an npm install, right? One more tip. The final and most important one. Take your mom out to dinner more often before it's too late. Thank you very much. Enjoy the rest of the conference.